Assalamualaikum warahmatullahi wabarakatuh and greetings to panel. Before we start, I want to introduce myself. My name is Muhammad Aiman bin Nasri and my final year project title is Investigation on the Air Filter with Industrial Ducting System. Chapter 1 is Introduction. We have background of study, problem statement, objectives, scope and significance of study. For background of study, since most people spend most of their time indoors, therefore indoor air quality should be maintained at a high level. In recent decades, various ventilation methods and devices have been developed to provide a comfortable thermal environment. The most widely used in industry is the local exhaust ventilation system or LEV system. The study of airflow related to velocity distribution being analyzed inside the air filter. For the problem statement, the usage of air filter in industry is the way to encounter indoor air pollution problem. Many air filter materials are commonly used in industry now, such as fiberglass filter, pleated filter, carbon filter, and high-efficiency particulate air filter. Besides, the velocity distribution and pressure behavior of air filter are analyzed and compared to experimental study to improvise primary method. Objective of study is to investigate the velocity distribution and pressure drop by using the computational fluid dynamics software or CFD software for air filter. Scope of study: the simulation will be conducted by using a model of air filter medium with fibrous filter, pleated filter, and HEPA filter. Analysis of velocity distribution and pressure drop in air filter media started from the inlet to the outlet of the system. The inlet diameter and outlet diameter for air filter models are 142.24 mm with area of 36,320.79 mm square. Total volume inside the air filter media are 13.829 exponent 6 mm cube. The inlet velocity is maintained at 2.7 meter per second based on the past experimental study. Computational fluid dynamics software (CFD software) used in this study is ANSYS Fluent Fluid Flow. The study of fluid mechanics involving velocity distribution helps people to understand about the pattern of fluid flow in various ways. The studies are essential as researchers study them for life and educational purposes. This research study is expected to provide the information about investigation of velocity and pressure distribution inside the air filter. The findings may be benefiting to others to get a new knowledge about the velocity and pressure distribution inside the air filter, and expected that the air filter will be used more widely as they give more benefits. For chapter 2 is literature review. We have 7 subchapters, which is LEV system, air filter, permeability, viscous resistance, airflow, pressure drop, and ANSYS Fluent simulation. For the LEV system, local exhaust ventilation is not a modern form of ventilation system. LEV system has been widely used in industrial application to provide an healthy and comfortable environment. LEV system consists of 5 elements here, which is a capture hood, duct, an air cleaner, a fan, and discharge. Air filter serve a healthy indoor air quality by removing harmful fine dust, including bacteria, pollen and molds, and other organic and inorganic material. Several air filters are widely used in the industry such as HEPA filter, carbon media filter, and fiber filter. Permeability. Permeability is defined as the ability of the filter to transmit liquid or gases or specific substance flow through it at atmospheric pressure. The permeability is determined determined using experimental data of pressure drop of clean filters at different filtration velocities. For a fluid moving with a slow steady velocity, the pressure drop through the filter and the velocity are related through the Darcy law. For viscous resistance, or we can call it viscosity, defined as resistance of a fluid flow. Viscosity plays an important role in filtration because it affects how quickly a fluid can be pumped through a filter to remove the contaminant. Principle of airflow. The value of volumetric airflow can easily be determined by calculating average air velocity through filter times with the cross-sectional area by referring to the equation Q equal to V times A, where Q equal to volumetric flow rate, V equal to average velocity, and A equal to cross-sectional area. Pressure drop. Okay, when air flows through a duct, it creates a pressure known as velocity pressure. When air is confined in the duct, it creates a different form of pressure that pushes itself in all directions at the same time. This pressure is known as static pressure. The total pressure is the value of static pressure and velocity pressure combined. Pressure drop is the difference in pressure between upstream and downstream. ANSYS Fluent Simulation. ANSYS Fluent is a computational fluid dynamics software that aims to analyze the system involving fluid flow, heat transfer, and associated phenomena such as chemical reactions. The Fluent Fluid Flow is one of the systems in ANSYS Workbench that can be set up and solve a three-dimensional turbulent fluid flow. For Chapter 3 is Research Methodology, Flowchart, Design of LEV and Air Filter, CFD, and Validation of CFD. Okay, for the flowchart, we start and then literature review, and then we determine of parameter involved and procedure, develop dimension model of the LEV system. Next, we import geometry from SolidWorks to the ANSYS Fluent, and then we apply the parameter and the boundary condition of a filter in the ANSYS, and then we simulate the project in the ANSYS simulation, and then we validate the data, and then we compare the result and preparing the discussion and conclusion. And for the design of LEV system and air filter, LEV we have a capture hood, 45-degree elbow, two 19-degree elbow, an air filter at the middle, and fan and exhaust type. And at the right hand side we have a model of air filter that consists of an inlet, an outlet, and a filter at the middle. Computational fluid dynamic software used to simulate the fluid flow in this project is ANSYS Fluent Fluid Flow. The CFD contains three main elements, which is preprocessor, solver, and post-processor. At preprocessor, we specify geometric and material properties, as well as the generation of solid and finite element models. At the solver, we solving the problems, and post-processor is a way to visualize and process the result obtained once the simulation run finished. Pre-processing, we have three here: geometry model, meshing, and GIT. Geometry model for fluid flow analysis can be designed in various software. For example, we can design in SpaceClamp or Design Modeler, or we can use SolidWorks and import into the ANSYS. For meshing is a process that allows the software to run calculation based on the domain. The mesh affected the accuracy and speed of solution. The GIT is performed to establish an optimal grade. GIT is required for the accurate result. Okay, GIT is performed to establish an optimal grade. The method that is used in this test is to reduce the cell size to obtain more nodes and elements number. As more nodes and smaller cell size used, the calculation should be more accurate. The result obtained become more accurate as the number of cells increases, while the computational time also increase. However, given that the mesh size is increased and the number of cells is increased, it is done when the result obtained do not impact the mesh size slightly. At post-processing. Post-processing is the result obtained from the simulation, such as velocity and pressure in the system. Velocity distribution in the system can be illustrated in the form of contour. Pressure, the determination of pressure is important to show the pressure drop occur in the system. The pressure drop also can be illustrated in the form of contour. Validation of CFD. The experimental data and parameters to conduct this simulation process are based on the past study reference validate of effect of air humidity on the evaluation of permeability and performance of a fibrous filter during loading with hygroscopic and non-hygroscopic particles. Chapter 4 is result and discussion. We have velocity vector, pressure result comparison, and validation result of CFD. Velocity vector for all tests. In this simulation, fibrous filter is used in test 1, while test 2 is pleated filter, and test 3 use high efficiency particulate addition, which is HEPA filter. The velocity result obtained in all the tests is explained in the form of the velocity vector. The highest velocity occurs at the outlet of the system for all tests, and the lowest velocity occurs at the filter media. Okay, there are three figures here. The velocity contour for three tests, test 1, test 2, and test 3. If we look at the table, test 3 has the lowest maximum velocity value compared to test 1 and test 2. And test 1 and test 2 have approximately same. The maximum value, average velocity, maximum velocity, average velocity, and suction velocity. Almost the same. But test 3 has the lowest maximum velocity, average velocity, and suction velocity compared to test 1 and test 2. For the pressure vector, for test 1, test 2, and test 3, we can compare by referring the table. Test 2 has the highest maximum pressure compared to others. Test 3 has the lowest. And for average pressure, test 3 also has the lowest, and test 2 has the highest. Same goes to inlet pressure. Test 3 has the lowest, and test 2 has the highest value of inlet pressure. Validation result of CFD. By referring the graph, it shows three different filtration velocity, that is 2 meter per second, 5 meter per second, and 15 meter per second, as well as two different humidity values of 32% and 90%. 32% humidity has higher pressure drop compared to 90% humidity because it has low permeability. The permeability of a filter are defined as the ability of the filter to transmit liquid, gases, or specific substance flow through it. This is a validation result of CFD. This is result from the simulation. At location 1 or at the inlet, 61% humidity has lower pressure compared to other humidity. 61% humidity has the lowest pressure drop because it has lower inlet pressure, and the outlet pressure as the same with others. So it has lowest pressure drop, which make it the most preferable filter. For the differences between 30% and 90%, because we want to validate the result with the experimental study, 30% humidity has higher pressure drop compared to 90%. By referring the table 32%, we have 57 5733.46 Pascal, and then 90% humidity we have 5549.82 Pascal. This is at the inlet pressure. This is because 32% has lower permeability value. Okay, for chapter 5 is sustainability. First is element in sustainability, concept of sustainability development, impact of engineering solution, and improvement of quality of life. Element in sustainability has three, which is social element, economic element, and environment. Social element require unity in the life of community and ability to work in the direction of shared objective. Economic element is financing to be actualized. Environment element is must be not affected the environment ecosystem. Concept of sustainable development. Sustainable development is a concept that tries to warning of the negative environment effects of financial development and globalization. Impact of engineering solution. The velocity and pressure distribution inside the air filters being studied and analyzed, then compared with experimental models. This method surely will solve the problems of engineers to analyze the velocity by using only simulation, so the time and cost will be saved. Improvement of quality of life. The main phase of life cycle assessment covering goal and scope. The product or service to be assessed is defined. A functional basis for comparison is chosen and the required level of detail is defined. Life cycle inventory. An inventory analysis of extraction and emission is performed. An inventory list of all the inputs and outputs of a product or service. Life cycle impact assessment. The effect of the resources used and emissions generated are grouped and quantified into a limited number of impact categories, which may then be weighed for importance. Interpretation. The results are reported in the most informative way possible, and the need and opportunity to reduce the impact of the product or service on the environment are systematically evaluated. Okay, that's all from me. Thank you for spending your time watching my presentation. Thank you.